Okay, so example problem 3. We have a building and it's 30 meters tall. Some poor kid was flying his kite near the building and it got stuck up on the roof. Now the kite string is still being held by the kid right here. And the string is taut, so it's nice and tight. And it makes this line, therefore giving us our triangle. Okay, so we have a right triangle here where the building meets the ground, a right angle I mean. So we've got 30 meters tall building, and the string that the kid is holding is actually 42 meters long, so a long kite string. Now the question we're being asked is, what angle does the kite string make with the side of the building? So if you look here, I drew the angle theta. We don't know what angle this is, but that's what we're trying to figure out. Okay, so the first thing we want to do is we're going to use SOHCAHTOA to figure out what trig function is going to help us. SOHCAHTOA. We have to figure out what trig function is going to help us get to the answer here. So let's check it out. We've got the hypotenuse, okay, the largest side of the triangle that's easily identified. So 42 meters. We also have this side. Now this side is not the furthest side away from the angle, so it's not the opposite side. It runs right along the angle on the side, so it's the adjacent side. So this is the hypotenuse side, and this is the adjacent side. So we got hypotenuse and adjacent, and we're solving for an angle. Which of the trig functions makes this work? So sine uses opposite and hypotenuse. Well, we don't have an opposite side, so we're going to just cross that out. We don't need that. Cosine uses the adjacent and the hypotenuse side. So cosine is going to be our winner. So I'm going to set up the equation. Cosine of our angle is equal to the adjacent side divided by the hypotenuse side. Okay, so we've got that set up. Now what we want to do is plug in our numbers. So I'll have cosine. I don't know the angle yet, so I'm going to leave it as theta. It's going to be equal to our adjacent side, which was the 30-meter tall building, and the hypotenuse, which is that 42-meter long string. So I've got this set up, okay? Now, what I can do right now, since these are both numbers, I can calculate what that fraction is equal to. So I'm going to divide 30 by 42, and I'm going to rewrite the equation cosine of theta is equal to 0.714. So there's more numbers after that, but I'm going to round it to 0.714. Okay? Now, the thing with the units is that the units actually cancel. So here, see, meters canceled with meters. So I don't have units to put on this number. But that's a small detail, not the main idea of this problem. The question is, how do we solve for our angle when we've got this set up? Okay? You can't divide the cosine over. That doesn't work. Okay? What we're going to have to use is what's called an inverse trig function. Now, all of the trig functions have an inverse. So examples, sine of theta, there's also the inverse of sine, which is just written as sine of -1 theta. That -1 power actually just shows you that it's the inverse, okay? So it's the same thing with that -1 on top. We have the same thing for cosine. With cosine of -1 theta. And then we have the same thing with tangent. Okay? And we can use these to cancel out our trig functions in order to get the angle all by itself. So what we're going to do is we're going to apply the inverse cosine function to both sides of the equation. So what that looks like is I'm going to take cosine inverse function, and I'm going to plug in my cosine of theta. Okay? That's going to help us cancel it out. But we have to do it to both sides. Everything you do on one side has to be done to the other. So cosine of -1, and then I plug in that 0.714, like that. So this is what our equation did. We did inverse cosine to both sides, okay? What that's going to look like over here is really useful. The cosines are going to cancel each other out, and we'll be left with theta. So we've got theta there. Now that's going to be equal to, here there's no cosine for it to cancel out with, so which means we'll have cosine inverse of 0.714. Okay, so we've got this, and we still aren't done because this is still not a number. We have to plug it into our calculator in order to get the number. So what we're going to do, okay, you already saw on the calculator that the trig functions are right here. Well, the inverse trig functions are normally right above them. Your calculator might be different, but I guarantee you they're going to be something similar where they're right next to it. In order for me to plug in those green symbols, I have to hit this second button. So if I hit second, the second button sends the little signal up here, and then any trig function I plug in will be sine of -1 or cosine of -1, whatever I want that to be. Okay, so for this problem, what I need to do is get the inverse cosine function and plug in 0.714. So what I'm going to do is I'm going to hit second cosine, so there's my cosine inverse of 0.714. I'm going to close that parenthesis, I'm going to hit equals. Okay, and so it looks like my answer is 44.43. Or it rounds up to 44.44. So I will round correctly. Theta is equal to 44.44. That's it, rounded to the hundredth place. And then what's my units for an angle? It's degrees. So I'll put a little circle there so that we know it's degrees. So that is how you solve for the angle in a right triangle using trig. If you guys feel like you want or need any more additional practice in the subject of this video, I put a link in the description to a couple practice problems and the solutions explained as best I can. So go ahead and check those out for some extra practice.